Hey everybody, Michael Snyder here, Pacific Northwest Weather Watch. Today we're going to do an educational piece on the Pacific Northwest and its greatest heat waves. We're going to do a case-by-case study from the 1950s all the way through 2021 June, the greatest heat wave to ever strike the Pacific Northwest. We'll look at similarities between those cases. And I'm going to do the temperature basis here on Seattle. It's where most of my research is done, but this applies to the entire Pacific Northwest here. So we'll look for similarities between these cases and check out just how extreme some of our heat waves have been in the past. So checking things out here, you can see this is April 1st, 1987. I picked this because this is the first day we ever hit 80 degrees in Seattle as far as seasonal temperatures here. So the earliest in the season, we hit 80 degrees at SeaTac. We set the record high the day before of 75 as well. I was 14 back then, and I can remember that heat being quite nice. You can see this ridge built all the way into British Columbia, kind of a classic trademark pattern of some of our heat waves here in the Pacific Northwest, deep troughing offshore, and this eventually kicked through and started to bring marine influence into the area through April 2nd, cooling us down. Heat waves usually in April and May are quite short-lived compared to once you start getting into June, July, and August, and we'll see that here coming up. Looking at the next case here on the list, we've got May 2008. This is the earliest 90-degree day of the season for SeaTac, May 17th there. You can see it. 84 the previous day there, early season heat wave. Check out this powerful ridge that developed here on the west coast of North America, built all the way into southeast Alaska, up towards the Yukon there, and across British Columbia here, bringing some really warm conditions early in the season back in 2008. You might remember that one. Checking out the next case set up here, as you can see that ridge disappear in 2008. This is the 1970 early June heat wave, early June's greatest heat wave, back-to-back 94-degree days for SeaTac here. You can see this ridging kind of build up over the area here, and the deep troughing over the Gulf of Alaska are helping with that ridge build all the way up through British Columbia towards the Northwest Territories and the Yukon here. So you're kind of seeing that pattern on how we build this ridging that needs to occur for our Pacific Northwest heat waves. As we get kind of an offshore flow with this big dome of high pressure, it flows over the terrain and it sinks and it warms as it gets out towards the coastline, and it will build up a thermal trough along the coastline for our best heat waves. And that's why we really warm up for western portions. In some cases, we can get even warmer than the east portions of the Cascades as well. So let's check out the next case here as we go on into the next one. We're going to do 1955 short duration heat wave, a scalding 96 degrees here in early June 1955, the day before, 85 degrees, nice and warm. You can see that ridge extending all the way up through British Columbia, all the way into the Yukon and Northwest Territories again. And again, you have the Gulf of Alaska troughing out here, and that helps build the ridging here. And you can see one extremely hot day, then we cooled down pretty good the next few days. But Seattle did see some distant lightning reported in the observations there, something of interest to note. And as we go into the next one here, the 1992 heat wave, late June, 3 days in a row at SeaTac hit 92 degrees. We had 5 straight days of 87 or higher during this period. And again, the classic signature big ridging here over the Pacific Northwest, the troughing out here near the Aleutians and the Gulf of Alaska. So here we go on into the next setup here. July 2015. A lot of you guys are going to remember this one here. We set a record by hitting 90 degrees for 5 straight days at SeaTac. It's only the second time we've done that. I believe the only other time was 1981. We'll check out that heat wave as well. And we had 5 degrees, of course, of 90 degrees or higher. We had 15 straight 80-plus degree days. Just an exceptionally hot summer there back in 2015. And you can see the troughing with the big ridge building all the way up through British Columbia here. Now looking into our next case here, let's go ahead and proceed along to July 2010. 3 straight days, 90 plus. You see the big ridge built there. And these 3 record highs, I believe, still stand to this day for SeaTac. And as we push on into the extended there, you can kind of see that ridge build all the way through southeast Alaska. Classic pattern. Gulf of Alaska troughing over the Aleutians as well. Now let's move on to the next case here. 2010 August major heat wave. We had a pretty darn hot summer of 2010. As you can see, look at this, 5 days in a row, 86 plus. 3 of those days were over 90, 95, and 96 back to back on August 14 and 15. So there's probably going to be a lot of you that remember this one around the region as well. As you can see, this massive ridge just built over right offshore the Pacific Northwest. Here we're looking at August 13th, so let's stretch that out a little bit more, 15, 16, 17. And notice the ridge just kind of hung around and kept that storm track out of the area here. Here was the last really hot day, August 17th, before we started getting marine influence into the Puget Sound area. Now let's move on to the next one here, 2009, the record-setting heat wave. This was pretty much the pinnacle of heat waves before June of 2021 last year occurred. Seattle, 103 degrees. That was the all-time record high. That lasted just about 12 years. And you can see we strung together 4 straight days of 90-degree plus temperatures. And after that 103-degree day, that cooled down to 96, you could actually tell it actually felt a little bit cooler. It's just a staggeringly hot temperature for Seattle, relatively speaking, anyway. Now, 2009, so that record high lasted until 2021. Let's check out the next case here. 1952 short duration heat wave. We're starting to get into August here a little bit now here too. And I put this one of note here because we were 25 degrees colder, 24 degrees colder on August 5th. So let's roll here through here. We're on August 2nd, 1952 here, 3rd, 4th, and there's the 5th here. You notice this trough just dropped down out of the north, really cooled off the area quite dramatically here. One of those savage marine pushes. Would have been nice to experience that one. Let's go on to the next case here, 1981. Now, this is one of the greatest heat waves of all time for the Pacific Northwest, except when you do take away the June 2021, of course. Now, you look at this, 5 straight days, 90 plus, 99. That's August all-time record high for SeaTac. The next day, a staggering 98. You can see the 5 days in a row of 90 plus, 7 straight days, 85 plus. And this is only the second heat wave to record 2 98 plus degree days. And of course, the other one was last year, June of 2021. But you can see the power of this ridge extended all the way into eastern Alaska, southeast Alaska, and all the way up into the mainland Alaska there and all across British Columbia, the Yukon Northwest. The ridge just really went northward on this one. And you can see as we go into the future here, there's August 9, there's August 10, and 11, and you can see that ridge remained strong all the way into August 12th here before we finally started getting some marine influence here at the end of the period. Now looking on to the next one here. Now this is still the same case actually. I wanted to show you guys this. This is 500 millibar wind speeds here, and you can see that trough, these powerful winds out here, well offshore, and you can kind of see the anticyclone building the high pressure over the region here. And as we move through this period, you can see some of this wind even just turns offshore, even at 18,000 feet here, just adding to that thermal trough that built up across the coastal areas up north. But you can see just how far north the jet stream was shunted here. And as we go on through a little bit further out, let's go out towards the August 11, 12 period here. You can see it just kind of kept this jet stream out of the area. We stayed pretty warm. So that was one of our greatest heat waves. You could even argue that it was our second greatest heat wave ever, behind June of 2021. Now we'll go on here into, this is 700 millibar temperatures. I wanted to show you this here because this is pretty typical of a summertime pattern. We get the marine influence and you get some, once you get to 10,000 feet, you're pretty chilly up there. But now watch as we put this into motion here as we went later into the heat wave. Look at the amount of heat that just built up all the way into British Columbia. And again, this is at 10,000 feet. There's exceptionally warm temperatures for 10,000 feet that built all the way up towards southeast Alaska here. So it just kind of shows you the strength of this heat wave back in 1981. Now, as we go forward a little bit more here, we're going out of this one. We're going to go to 1988. We're now looking at September's greatest heat wave for Seattle. You can see 85, 98, and 92. 98 of September 2nd is the highest ever September recorded temperature for Seattle. You can see this ridge expanding all the way up into the Yukon Northwest Territories again, and the classic troughing out over the Gulf of Alaska back towards the Aleutians as well, hoping to build that ridge. So remember this troughing out here. That's going to be an important point that I make here coming up for the 2021 heat wave that we're going to look at in some detail as well. But you can see here 500 millibars. You see the ridging and some of the offshore flow occurring here with this setup. So another impressive heat wave that was back in 1998. I can remember that one too. Pretty hot day on that 98-degree day in September. But you can see that anticyclone just maintained all the way through September 3rd before we started getting some marine influence. So here we're taking a look at the June 2021 Massive heat wave for the Pacific Northwest, and this is probably going to be the heat wave that all other heat waves are measured against for as long as you live here in the Pacific Northwest. A truly rare event. You can see Seattle over 100 degrees 3 days in a row, 102, 104, 108. We broke the all-time record high on June 27th. It didn't even last 24 hours before we broke it again on June 28th. Then we dropped back down 23 degrees on the 29th, but still 85 degrees is a pretty hot day in Seattle in its own right. So as we move into the ridge position here, look at how this ridge just set up shop perfectly over British Columbia and Washington. I'm not sure you can draw it up much better here, folks. Big heat dome over the area, strong offshore flow, thermal trough came up the coastline. Perfect right up for a significant heat wave here in the Pacific Northwest. Now, as I go into the 28th and 29th, you can see the feature moving up with the thermal trough, and finally the upper level ridge is weakening, and we start to bring some marine influence here on the night of the 28th into the 29th, where we cooled down quite a bit. Remained warm over eastern portions though, but for the most part, that was the end of the heat wave across the region. Now looking at 500 millibar winds here, and you can just see the perfect nature of this anticyclone. I mean, you can't draw it up much better than that. Like I said earlier, 70-kilometer winds in the wraparound jet stream back across offshore here. It's just really exceptional. You can see just how strong this flow was out of the south all the way up into Alaska and back around through British Columbia, forming that ridge across the region. Now, as we go a little bit further, you can see that ridge weaken, push off to the east, and you see that feature coming up the coastline there eventually brought some marine influence into western Oregon and Washington, British Columbia there on the 29th. So now as we move a little bit more into 700 millibars, 10,000 feet, pretty typical summer pattern here. 10,000 feet, you're pretty chilly. So you can see it's warmer down towards the southwest, of course, chiller up towards Alaska and Canada as per usual. But now watch how this heat builds up here on the 26th, 27th. Just an incredible dome of warm air all the way up to 10,000 feet. Some places on Mount Rainier above 10,000 feet were over 70 degrees, caused some huge glacial loss on the mountain here. The most in recorded history here on Mount Rainier. A pretty incredible sight watching that north face just be really devoid of snow and ice last summer. So as we go through now 850 millibar temperatures, I kind of want to show this one to highlight this thermal trough here. You can see this just extended all the way into British Columbia, 80 plus degree readings well out over the Pacific Ocean here on this very warm night of the 28th there. But you can see this feature out here that eventually brought some marine air through the region. But just a truly incredible thermal trough across the region here last year in June. Now looking here, 850 millibars winds just kind of show that offshore feature here. The morning of the 28th into the 29th here, we're still going a little bit offshore here, but then we started to bring that marine influence back in. But look, if we go back to the 26th and 27th, you can kind of see that offshore flow going there at 5,000 feet, bringing those extremely warm temperatures on the 28th. Now, as we look a little bit closer here, this kind of shows the same feature there, 26, 27, and almost to the 28th there. You can see the morning of the 28th, we were still going offshore pretty well here, which allowed us to warm up so well on the 28th. Now, as we go on in through the surface pressure here, you can see the ridge offshore, and you can see that high pressure kind of move down the backside of the Rockies, eastern Washington here as we go on in towards the 26th and 27th. And you'll see that little subtle feature of the thermal trough now moving up the coastline here on the 27th here. And on the 28th, it really gets going. The morning of the 28th, it was at its peak strength here. You can see the higher pressure here. And of course, this wants to move out across the terrain towards the lower pressure here. And that's a signature of all the great heat waves for Seattle, Portland, and Vancouver is that thermal trough. We'll take another look at that here in a wider view coming up. Now looking at 300 millibar winds way up in the atmosphere, and you can see that jet stream, Gulf of Alaska here, there's Anchorage, there's Seattle, San Francisco, Hawaii, Pacific Ocean, and you can see this trough digging out here, and this allowed for some extreme ridging over the Pacific Northwest. So we go in through the 25th, 26th, you can see that anticyclone builds all the way up into northern Canada here. Just a picture perfect position for the Pacific Northwest heat wave. Now 500 millibars, 18,000 feet. You can see this pretty cold air here associated with this trough. And we had some tropical energy moving along with this really tight gradient. That's what allowed this trough to dig so far down and bring air back up in front of it, and that's what caused that extreme ridging. So this tropical system combined with this cold air aloft is really what drove this trough in this ridge and created this heat wave. At least that's my theory anyway. I think it's probably would be pretty well supported. And as we go on in a little bit more, you can see the ridging just really build up there on the 26th, 27th, as it just perfectly forms over the Pacific Northwest. Now looking at 700 millibars here, I wanted to show this because you can see that cold air aloft and some subtropical air aloft. The tropical system was not that strong, but it's enough when it meets up with cooler air aloft to really increase the gradient here and increase this trough strength, which can drive that downstream ridging across our area here in the Pacific Northwest. And now this is another view of 10,000 feet temperatures here. You can see just how much this heat established itself along the coast of North America. I mean, you can look at the temperatures above Hawaii here. We were actually warmer than they were out here across the tropics at 10,000 feet. Pretty exceptional. Now looking at surface pressure, here, as we go into the 24th, 25th, 26th, that thermal trough is building. Going to the 27th at nighttime, you can kind of see the feature pretty plainly here along the west coast. And again, classic signature for Pacific Northwest heat waves is the thermal troughing here. You can see the higher pressures over the inland areas, which forces that air out across the terrain, sinks, warms, and causes that thermal trough and allowed those temperatures to just soar across the region. Now taking a look here, let's speed ahead to the 28th here, and you can see that was 28th morning, and here's Portland. We're getting into the afternoon hours here, but you can see just how much the heat was building up going on here on the 28th. Portland 116, Salem 117, Medford 115, the Dalles, Oregon 118, an amazing temperature there. The all-time record high, for example, for Las Vegas, Nevada is 117 degrees. The Dalles, Oregon beat that. Spokane 109, Yakima. Bellingham actually hit 100 later in the summer, if I'm not mistaken, with some offshore winds. Olympia, a staggering 110. Seattle 108. Quileute, Washington hit 110 on the coastline near the Hoh rainforest out there. Their previous record high was 99. That 11-degree difference was one of the most stark record temperature destructions in recent history that I can ever remember for any place really in the United States. Just an incredible record out there for Quileute. So now as we wrap this up here, you can see that the main feature is the big ridging that builds up over the west coast of North America, and that is in turn associates with some thermal troughing off the coastline here with offshore flow. And you can kind of see how this case by case, we had built these big ridges with our biggest heat waves across the Pacific Northwest here. And of course, culminating in our June 2021 heat wave that we had last year. So we will do something similar to this, but we will flip it around and do it with our cold air intrusion. So we'll check out the upper level of the atmosphere. We'll check out 500 millibar temperatures. We'll see what it takes to bring cold air into the region and just why it's such a chore to try to get cold air across some of the Rocky Mountains and the higher terrain of British Columbia into Western Washington. We'll look at that, and I'll probably have that ready for later on into fall towards winter when we start getting a little bit more hyped for winter weather. I want to do some local features. I've got a Puget Sound Convergence Zone video in the works as of now, so I'll be releasing that probably in the next month or two. We'll look at some of the features: Chehalis Gap, Strait of Juan de Fuca, the Gorge, Fraser River Gap, Okanagan, Purcell Trench, some offshore winds. We'll look at all kinds of little features eventually, but let me know if you have anything in mind specifically, and we can try to go over that, or I'll put it on my plate for a later date. Otherwise, I will probably do a forecast for tomorrow as well. We'll check out just how warm we're going to get for Monday and Tuesday of next week. Some nice heat coming in here, but nothing close to what we had last year, or even with some of our greater heat waves. This is a much more mild warm up here for the Pacific Northwest. But yeah, leave some comments below, like and subscribe, and I'll talk to you guys tomorrow.